Good morning, scholars, or good afternoon, whatever time you're watching this. Just like with every other week with science, I'm going to help you out by reading through the text so that way you can focus on your science and not on the reading. So if you are in your packet, you can follow along with me. Or if you're just watching right here on the screen, I'm going to go ahead and I'm going to show our science. So without further ado, here we go. Let's go ahead and read. So our activity this week, you're focusing on planning and carrying out investigations. So if you already watched my other video, you're going to understand what all of that means. So right now we're going to be reading. This is activity number 1, Marvelous Matter. Lesson 1, Matter Matters. Directions. Use the information below to complete the activities. Right there. What is matter? From the stars in the night sky to the sands on the beaches, from the air we breathe to the fizz in our sodas, from the planets in the solar system to the rocks and water on the earth, everything in our entire universe is made of matter. Different kinds of matter have two things in common. They all take up space and they all have mass. So we have that graphic source. Make sure you take a moment to look at that graphic source and ask yourself what it's showing. Continue reading right here. Have you ever mixed a Kool-Aid packet with water and sugar? Or mixed sugar in water or iced tea? What happened to the sugar? Some matter, like sugar, can also be dissolved into a liquid and we can no longer see it. This is another way matter can change form. Where did the matter go? When sugar is dissolved in water, it seems to disappear, but it didn't. The sugar simply dissolved into the water and you could no longer see it. If you were to boil the water until it evaporated, a change from liquid to gas, the sugar crystals would reappear. They were there the whole time. So right here we see the picture of that. We see the person holding the spoon, mixing in the sugar, and there's that sugar there where if all the water evaporated, it would still be there. If you build a campfire, you start with a big pile of logs. As the fire burns, the pile of logs slowly shrinks. By the end of the evening, all that's left is a small pile of ashes. What happened to the matter that you started with? Was it destroyed by the fire? It may seem as though burning destroys matter, but the same amount of matter still exists after a campfire as before. When wood burns, it combines with oxygen and changes not only to ashes, but also to carbon dioxide and water vapor. The gases float off into the air, leaving behind just the ashes. Suppose you had measured the mass of the wood before it burned and the mass of the ashes after it burned. Also, suppose you had been able to measure the oxygen used by the fire and the gases produced by the fire. Here's a picture that shows that. You see our start with all the logs and the fire, oxygen coming in, carbon dioxide and water vapor going out. At the end, our pile of ash and these question marks making us wonder, where did it all go? We're going to find out. What would you find? The total mass of matter after the fire would be the same as the total mass of matter before the fire. So this means that if you take all of these things together and add them up, at the end, what's left plus everything that's up there would equal the same because you cannot create or, you cannot create or destroy matter. Let's continue reading. We'll start right here where I highlighted what. What does the sugar, water, and campfire examples prove? Even when matter changes its state or seems to disappear, it is not actually destroyed. These examples illustrate a very important concept. The amount of matter is conserved when it changes form, even in transitions when it seems to vanish. Matter cannot be created or destroyed. Even when matter changes its state, the total amount of matter always remains the same. So now if you're working in your packet, you'll go ahead and answer these questions. If you're on Google Classroom, you also have these as fill in the blanks, but you're going to use what you just read to complete these sentences. So everything in the entire universe is made of, what's the word they kept repeating? Matter. Matter makes up everything. We know that matter cannot be created or destroyed. So however it is, think about an ice cube. If you've got an ice cube, when it melts, it turns into water. It's the same amount of water back and forth. So it cannot be created or destroyed. And matter can be changed from one state to another form, or from one form to another form. Again, like water. You could have a glass of water. You could freeze it into an ice cube, or like if you're boiling water to make pasta or something, you see all the steam coming out. So matter can be changed from one form to another form, or one state to another form. You still have a little bit of reading. Okay, I'm going to read this part for you, and then you're going to complete your activities. So you're going to use the information below to complete the activities. Now, I'm hoping this is something you've done at home. So a student wanted to make Jell-O gelatin. Yum! 100 grams of Jell-O powder was mixed with 600 grams of warm water in a bowl. The bowl was covered and put in the refrigerator. A few hours later, the student took the bowl out of the refrigerator. There had been a change to the mixture. The mixture was now somewhat of a solid form. I mean, you guys, I'm hoping to have seen Jell-O. You know it's mostly solid, but it's got that little bit of a jiggle. So we know that it's now in a mostly solid form. And here's a picture of Jell-O cut out into shapes after refrigerated. Below is a graph of the masses of the mixture before and after the Jell-O was refrigerated. So our title of our graph says masses before and after the change. Our x-axis has before with Jell-O powder and warm water, and after has Jell-O. Our y-axis has the mass in grams. So make sure you're looking at those labels. And then you're going to use the data from the graph to answer the questions. Okay? So if you're in your packets, you'll have your questions there. If you are on Google Classroom, you will have everything you need to know there. Okay? Where it says lesson 2, we are not worrying about lesson 2, just lesson 1. Okay? So good luck, scholars. I know you will do a fantastic job. I hope this was helpful to hear through your text. Okay? So until next time, we are super proud of you today and every single day. And I'm very excited to see all the stuff you're doing for science. And until next time, goodbye, scholars.